Hello, everybody. So today, let me get this out of the way. We are talking about solving logarithmic equations. Sorry, my husband is like watching a movie. I don't really know what he's watching. He's been watching The Flash recently, but I don't know what he's doing right now because I heard them talking about vampires, and I don't think that's in The Flash. Anyways, it's loud, so I needed to close the door. So we are talking about solving logarithmic equations today. Also, this is the last day of online learning. Thank Jesus. This has been the longest, most difficult thing ever. And I'm very concerned that we're gonna maybe have to do it in the fall. I think I told you guys in a different video that I'm pretending like that's probably gonna happen to keep my hopes low. So I'm not disappointed. But I don't know. We'll see. Okay. Anyways, congratulations on getting to your last day of online learning. I feel like we should have like I should have made baked goods and then mailed them to you. I don't know. So that we could have like a party. So go get your favorite snack and have your favorite snack while we are taking notes, I guess. I don't know. Or I could like film me watching. We could pick a movie, cool math movie. We should have like filmed ourselves watching it on Zoom or something. Anyways, I let all of you guys down. We're not doing any of those things. We're taking some notes. So last class we talked about solving exponential function or equations, and now we're talking about solving logarithmic equations. So let's jump right in. So first we have this example, log base 3 of 4x minus 1 equals 3. So the first thing we want to do, you can go to your formula booklet and you can use the conversion that they use between logarithmic and exponential form and just do that. Or you can imagine it as, I don't really know how to say it correctly. You're raising each side with the base e. So the thing that, or not necessarily e, but whatever your base of your logarithm is. So the thing that's in the equation becomes the exponent, and that we're creating a new base, basically. So this one had log base 3. We need to undo that, which means we need the exponential function with the base 3. So the logarithm and the base here are going to cancel, leaving us with 4x minus 1 equals 3 to the third power. Okay. Then 3 to the third power is just 27. Add 1. 4x equals 28. Divide by 4. And x should be equal to 7. Cool. You try the next one. Hint, it's going to be base 2. So you're raising both sides with base 2. I'll post solutions. All right. So just a minute ago, I messed up, and so I cut the last part out of the video, and I am fixing my mistake. So my mistake was, I was like, oh, I could just raise each of these pieces with the base 7. That doesn't work because you have to do the whole side of the function with that base, not just each term, okay? It's kind of like squaring both sides of the equation. I can't square this piece and square that piece and have it still be equal to this square. I would have to square the entire thing, right? Squaring the sum of two things is different than squaring each individually. And then adding them together. And so what we have to do is we have to combine this logarithm before we start. So we're going to use our logarithm properties. So when we have them added with the same base, we can multiply the insides. So really this is log base 7 of 2x minus 3 times 4x minus 5. Then that's going to be equal to 0. Okay, now instead of worrying about all the stuff on the inside, now I'm going to get rid of the logarithm. So to get rid of the logarithm, I raise each side with the base 7. So I'm going to have 2x minus 3 times 4x minus 5 equals 7 to the 0 power, which is 1. Okay. Now I'm going to distribute everything. So I should have 8x squared minus 10x, nope, minus 12x. Other mistake. Mistakes all over the place. Whatever. They help us learn, right? And then 3 times 5 is positive 15. 1. Okay. I'm going to combine my like terms. So 8x squared negative 22x. And then I'm going to subtract 1 from this side and that side to get plus 14 equals 0. I'm going to factor out as much as I can. So the factors here are 2 and 11. 11 is prime, so the only factor that all of them have in common is 2. So I'm going to factor out a 2. Okay. And then I'm going to go ahead and do, if you know a different method, if you do slide and divide or whatever, well, we would get rid of this 2, right? Do whatever you want. I'm going to do the cross and box method. So A times C is 28. B is negative 11. So I'm looking for factors that multiply to 28 and add to negative 11. So 28 is 7 and 4, which works. So negative 7 and negative 4 will give us that negative 11 and also the positive 28. So then I am going to go off to the side. I put my first term here, 4x squared. I put my last term here, and my factor with an x, and my factor with an x. And so the factor here is 1, the common factor. The common factor here is x. The common factor here is, oh no, it's going to be super tight, negative 4x. So negative 4x. That's supposed to be negative 4x. Okay, and then here the common factor is going to be negative 7. I think it just kind of looks like a 7. So there's, oh my gosh, so bad. Negative 7. Sorry, guys. Okay, so now we know that our factors of this are, oh my gosh. Also, I'm pretty sure that this should be positive 4x. And then this should be negative 1. Yeah. Because we want the negatives to be in the terms that have just a constant value. Because this 4 is positive, we don't want either of them to be negative. So we would have 4x minus 7 times x minus 1 equals 0. So this will give us the 4x squared, negative 4x, negative 7, giving us the negative 11x, and then our positive 7 is our last factor. So when we set each of these equal to 0, we should get x equals 1 and x equals 7 over 4. Now, let's see. These are two solutions. Let me look at this for a second. The person who originally did the solution says that x equals 1 is not a solution. So if I sub in, oh, and I see why. So if I sub in x equals 1 here, I get 4 minus 5, which is a negative value, and you can't stick negative values into logarithms. So this is not in the domain. So it's not a solution. So the only one that is a solution is the 7 over 4. That would give me 7 minus 5 here, which is positive. 7 over 2 minus 3, which is still positive. Okay. Yeah, because 7 over 2 is 3.5 minus 3 is 0.5, still a positive value. Okay, so you try the next one and then I will post solutions to it. Then don't forget to check each of your answers. You may not have, or you may not have a negative or 0 on the inside of a logarithm.